Hello everybody, this is a presentation on systems of simultaneous equations. Now mainly the ones that I'm interested in are these ones that are kind of new to you this year from exercise 2F. What I've done here is I've said what I want you to do is find the value of A for which the system has a unique solution. Now let's think about this. If we were to, what we'll do is we'll take this equation number 1 and this equation number 2, and for each of them figure out the gradient for each. So if I take number 1 over here, a minus 1x plus 5y is equal to 7, I'll take this and put it over to the other side. So if I do that, I'll end up with 5y is equal to minus a minus 1x plus 7. Next what I'll do is I'll divide both sides by 5. Now if I do that, I'll end up with y is equal to minus a minus 1 x over 5 plus 7 over 5. So in equation number 1, the gradient is minus a minus 1 over 5, and the y-intercept 7 over 5. Now let's do the same thing with equation number 2. Alrighty, so let me take that across to the other side. So I end up with a minus 3y is equal to minus 3x plus 3a minus 1, and I'll divide both sides by a minus 3. Now if I do that, y will be left on its own, and the gradient will be minus 3 over a minus 3x plus 3a minus 1 over a minus 3. That will mean the gradient of equation number 2 is minus 3 over a minus 3, and the intercept would be 3a minus 1 over a minus 3. Now what I'll do on the next page is equate the gradients together, because if the gradients are equal to one another, then we've got two situations. Either we'll have no solutions or infinite solutions. Okay, now what we want to do here is to say, okay, well if we have two gradients that are equal to one another, the lines will either be parallel, that is one next to the other, in which case they'll have no solutions, or right on top of the other, which means they'll have an infinite number of solutions. Now what we'll do is we'll make one gradient equal to the other one. So that would mean minus a minus 1 over 5 is equal to minus 3 over a minus 3. Now we'll cancel out the negatives, so we'll cancel that with that, and we'll take this one and put it up there, and this and put it up there. So if we cross multiply here, we'll end up with a minus 1 times by a minus 3. Now if we expand this, this is a quadratic. We'll have a squared minus 4a plus 3 is equal to 15. Now if I take the 15 across to the other side, let's see, if I minus 15 from each side, those will cancel out, and I'll end up with 0 on this side, and 3 take away 15 is minus 12. Now if I factorize this, that'll be a minus 6 and a plus 2, which would give me either a could be equal to 6 or a could be equal to minus 2. Now, to answer the question that I originally had, for a unique solution, the gradient can't be equal to one another. A could be equal to all real numbers, so any element of the real numbers, except for a value of a that makes the lines parallel. So we could, as long as a wasn't equal to minus 2 or a wasn't equal to 6, we wouldn't have parallel lines and would have one solution. What if I asked you for another problem and I said, well, what value of a would give you an infinite number of solutions? Well, when the gradients were equal to one another and the intercepts were equal to one another, then we could say there is an infinite number of solutions because the two graphs are the same as one another. So if we say, okay, well, what are the gradients equal to, the y-intercepts equal? One of the y-intercepts was 7 over 5, and the other one was 3x minus 1 over a minus 3. Now if I cross multiply it again, that up there and that up there, I'd end up with 7, a minus 3, 5, 3a minus 1, and if I expanded those, 7a minus 21 and 15a minus 5. Now what I'll do is I will plus 5 on this side and on this side, those will cancel out, and I will take 7a from each. Now 7a take away 7a cancels out, and minus 21 plus 5 is minus 16, and 15a take away 7a is 8a. Now if I divide it on both sides by 8, a would be equal to minus 2. I could say therefore, if the gradients were the same when a was equal to minus 2 and the intercepts were the same when a equals minus 2, therefore for infinite solutions a must be equal to minus 2. Now for no solutions, that must mean the gradients were the same but the intercepts were different. Now the gradients are the same when a equals 6, but the intercepts are different. That will mean when a is equal to 6, they'll both have a gradient that is the same, these two linear graphs, but they won't have the same y-intercepts, so they'll be parallel and different graphs. Alrighty, well I hope that helps. I'll see you in class if you have any more questions.